This project aims to understand and bridge the gap between theoretical advancements in audio detection and their practical applications. We explore the challenges of implementing neural networks on low-cost devices.
This is a demo for WASPAA. Press the red button to start and get sound notifications.
Recording. Stop recording.
We used a Raspberry Pi 4 with the Google AIY voice kit, which includes a hat board, microphone optimized for voice, a speaker and cables. We installed the PAN software for audio detection. The hardware audio tagging system offers several useful features for real-time applications. It allows for the detection of indoor sound events such as crying babies, open faucets, or fire alarms. It sends email alerts when specific sounds are detected for added security. It generates a remotely accessible web page that displays the detected events and the CPU temperature. The system operates with a button. Upon pressing it, audio starts recording into a buffer. The PAN software then analyzes the recording and notifies of the audio events detected with the highest confidence. It also monitors the CPU temperature. The results show that compared to the software-based system's 92.8% accuracy when directly reading audio files, the hardware-based audio tagging system correctly identifies 80% of sound events. A higher sound pressure level improves the prediction of the hardware-based audio tagging system. The average operating temperature of the Raspberry Pi is 55 degrees centigrade, rising to 80 degrees centigrade during inference. This rise triggers a slowdown in clock speed to prevent burnout, causing a 20% increase in the inference latency.